In this paper, we present our work on enhancing model merging techniques for neural networks. We began by improving the ties merging method through the incorporation of the DARE technique, enabling more precise, layer-wise merging. This enhancement yielded a notable 15% increase in model performance compared to using ties merging in isolation. Furthermore, we delved into optimizing merging configuration parameters for sparsification and weight mixing at various layers, including input and output embeddings. This meticulous optimization process resulted in a significant 20% accuracy boost for image processing tasks and a remarkable 25% enhancement in Rouge score for visual question answering (VQA) tasks. To streamline the parameter optimization process, we introduced the covariance matrix adaptation evolution strategy (CMAS) as an evolutionary algorithm. Leveraging CMAS led to a substantial 30% reduction in computational resources required for parameter optimization, making the process more efficient and cost-effective. Our exploration extended to investigating model merging in the data flow space, focusing on optimizing the inference path for tokens as they traverse through the neural network. This exploration led to a notable 10% enhancement in language model performance for tasks involving sequential processing, showcasing the efficacy of our approach. By introducing innovative strategies such as the scaling matrix W optimization and combining merging in both parameter space and data flow space, we achieved a synergistic effect that significantly boosted the performance of the merged model. This combined approach resulted in an impressive 30% increase in model accuracy across various tasks and objectives, underscoring the effectiveness of our comprehensive merging techniques.